Okay, so in last class we did all questions based on VI characteristics or Ohm's law we did. Then today we can start with resistors which are in parallel and series. Okay, so yeah. So we can go for resistors. Okay. So basically resistors are connected in two ways. So that are nothing but series and another is parallel. Okay. In series means we are connecting the resistor back one by one or ending of one resistor and starting of one resistor. We are joining together. Here very important thing, current I will remain same in an entire branch, okay, but voltage across this resistor is different and voltage across this second resistor is also different, okay. Voltages are not same in series but current in the entire branch will remain same. And in parallel combination, here resistors are connected in a parallel. How you can identify they are in parallel? Because here current I gets divided into two branch, means half current is going through resistor R1 and some current is going from the resistor R2. Okay, again it is get combined and here I amount of current only flowing. But if you consider this loop here, the current is what get divided and that's what this circuit is known as a parallel circuit. And here voltage across each resistor will remain same, that is V only, okay, it will not change. But current across this resistor is I1 and current across this is nothing but what, I2. Can you get it? This is what the difference in between parallel and series. Okay, in parallel the current is gets divided and voltage will remain same, and in case of series the current will remain same and voltage is what gets divided. And we are getting the equation in case of series here, R1 plus R2. Okay, we will get the equation, final expression, resistors are in series, R1 plus R2 and so on. This is the expression we are getting. How we will get this? So here we know that total voltage is nothing but this voltage across R1 and voltage across R2 is V2. So according to Ohm's law, we know that V is equal to I into R. So V1 is nothing but what? I1 R1. Okay, or current is here I, only I amount of current is going, and V2 is nothing but what, I into R2. So this is nothing but, V is nothing but what, I into R. So capital RS I am writing, and I into RS, if I take I common here, so R1 plus R2, I and I get cancelled and we will get the expression R1 plus R2. Okay, so how we can prove this also? Okay, but this kind of question, even proving question also comes for 3 marks. So they are asking you what are the, how the resistors are connected in, how the resistors we can connect, okay, and how many different ways we can connect, and explain any one of them. So you can go either series or parallel. Sometimes they will ask you directly to prove the series or to prove a parallel also. So here how can you find out? Here we will get in this case 1 by Rp is equal to 1 by R1 plus 1 by R2. So how can you solve this? Here voltage will remain same. Okay, here voltage will remain same. So how can you calculate? Current is gets divided, no? So total current I is equal to what? I1 plus I2. And again according to the Ohm's law we know that V is equal to IR. So I is nothing but what? V by R. So here I is nothing but V by R. I will substitute. I1 is there across R1. So I will write voltage will remain same by R1 plus V by R2. Okay, so I will take here V common this side. So if I take V common, 1 by R1 plus 1 by R2. Okay, V get cancelled and 1 by R is equal to 1 upon R1 plus 1 upon R2. So this is what the expression we are getting. Okay, so can you getting this expression? Very important expression. Mostly they will ask the expressions. If you know how to solve this, then that would be a better, because many questions will come for a parallel and series combination. Okay, finished. Everyone took a screenshot. Okay, then along with that I will explain you heating effect of current, as well as I will explain you the Joule's law of heating. Heating effect of a current is nothing but whenever we are passing a current through it, okay, passing a current through the circuit, then amount of heat is generated due to the conduction of an electron. Okay, that is called as a heating effect. Okay, and that produces a heat. That is heating effect. And here Joule's law of heating is what? Joule's law of heating, where the heat is produced in a conductor, and that heat is what? Directly proportional to the square of the current. Okay, according to the Joule's law, heat is produced in any conductor or any device is directly proportional to the square of the current through it and resistor and time. We can say that it is directly proportional I square R into T, or you can write H is equal to I square R into T. That is current, resistor and time. This is nothing but what? Heating effect in the resistor, and this we can write it as VIT also. Okay, H is also we can write. Suppose here I have V is equal to IR, then I is nothing but V by R. So I will substitute here I is nothing but V by R, and here square is there. So V square by R square into R into T. Okay, 1R is get cancelled. V square by R into T. Okay, or we can write here R. No, R is nothing but V by I. We can write R is nothing but V by I. That also we can substitute here. H is equal to I square. R is nothing but V by I into T. I and this one I is get cancelled, and we will get the answer V into I into T. That is nothing but what? Amount of heat generated. This is what the Joule's law. Sometimes this Joule's law they will ask for as a question, define and explain or state and explain the Joule's law and the equation. So you have to write this much. Okay. So here some applications of the heating effect of electric current we have. So actually this heating effect is utilized in the electrical heating appliances such as electric iron we have, then room heaters, water heaters. Okay, iron we have. So these are the examples of heating effect. They can produce what? A heat. And even electric bulb is also known as comes under the heat producing element, because as tungsten temperature is increases, more and more light is what started emitting. Okay, and this is nothing but what we can also known as this H. Okay, H is also known as a work done or energy, because heat energy is also one kind of energy. And very important, all heat, work, heating effect in Joule, whatever H and this work done we are getting, that is everything is measured in terms of Joule. Okay, then this is what the heating effect. And whenever we learn this heating effect, then many students have a questions. Oh, this much amount of heat is producing, then one stage will come, the electrical devices are what gets damaged. So yes, of course, this amount of heat is generating in the devices, then definitely there is a heat, due to heating effect some appliances are got damaged. Okay, and if there is a no control on heat, then it is what started producing more and more heat, and there is a sudden shortage or short circuit will takes place. But how the short circuit will takes place? Because of the electric fuse. Okay, so electric fuse is nothing but what? One safety device, and this safety device we are using in the electrical appliances in case of short circuit or overloading. Okay, and this fuse is basically made up of pure alloy, pure tin or alloy of copper and tin. Okay, and fuse is connected always in series with the live wire. Okay, so we have positive, negative and live wires are there. So fuse is always connecting. Fuse is connecting in series. Okay, and that is connected with live wire. This is very important. Many times this question will come for 1 mark or MCQ or reasoning assertion. Okay, this fuse is always in series with the live, and fuse is having what? Low melting point. This also very important. Fuse is having what? Low melting point. Low melting point. Okay, so these are the characteristics of the fuse. And current capacity of a fuse is slightly higher than the appliances. That's what fuse is used in the circuit. Of course, it can short the circuit, means it can avoid the, if there is a overloading also, it is started melting by itself. Okay, that means it is having higher capacity than the other electrical appliances, and it is connected with series, and it is connected series with the live wire, and they are having what? Low melting point, and they are what? Having the current capacity is slightly higher than the other appliances. Can you getting up to here? Take the screenshot of this. Is everyone getting? Okay, so everyone took the screenshot. Now next point is the electrical power. I'm just giving the idea, then after that we can start numericals. Okay, the next point is nothing but power. Power is nothing but V, voltage into current. Power P, it is denoted by letter P. P is nothing but V into I. It is a product of voltage into current, and any electrical energy is consumed or dissipated in the electric circuit is nothing but power. Okay, so we can write power here. We can make a changes according to the given requirement. V is nothing but again IR. So I will keep here I into R into I, that is nothing but I square into R. This is P. Okay. Then R is nothing but we have V by I. So here P is nothing but I square. R I will substitute as a V by I. So I and I get cancelled, and I will get it as a V into I. Okay. So this is also we have a formula. Even we can make a modifications, and we can write here V square by R. So these are the three important formulas for the power. Okay, P is equal to I square into R. P is nothing but V into I, and P is equal to V square by R. Okay, so these are the formulas we have. Power is measured in terms of watt. Okay, watt we are measuring in terms of watt, and we are denoting by letter W. Okay, and here commercial unit of electric energy is nothing but kilowatt hour. This is commercial unit of the electrical energy, that is kilowatt hour. And when we can say that there is a 1 watt of power is generated, so whenever there is a 1 amount of voltage and 1 ampere of current is flowing through the circuit, in that case 1 watt power is generated in that circuit. Okay, and always remember 1 kilowatt hour is nothing but 3.6 into 10 raised to 6 joule of energy we have. Okay, 3.6 into 10 raised to 6 joule of energy. Okay, getting up to here, everyone is getting. Okay, so just take a screenshot of this and revise. I will give some papers to 12th standard students and I'll come back. Okay, I'll give it. They are coming for a paper now. Okay, chalo, we can start. So, everyone understood the theory up to here? Do you have any doubts up to here? So, if not, then we can start. So, write down some questions. Write down 2 bulbs of 100 watt. 2 bulbs of 100 watt and 40 watt are connected in series. Full stop. The current through the 100 watt bulb is 1 ampere. The current through 100 watt bulb is 1 ampere. 1 ampere. Then the current through the 40 watt bulb will be. The current through the 40 watt bulb will be. Okay, so try to find out this. I'll repeat this question. 2 bulbs of 100 watt and 40 watt are connected in series. Full stop. The current through 100 watt bulb is 1 ampere, is 1 ampere, the current through the 40-watt bulb will be option A 0.4 ampere, 0.4 ampere, option B 0.6 ampere, 0.6 ampere, option C 0.8 ampere, and option D is 1 ampere. Try this. Powers of the two bulbs are given here. Okay, and the current through a 100-watt bulb is 1 ampere given. Okay, find out the answer for this. Check how can we solve this. Can you getting the answer? Okay, so it is a basic concept. If you are not able to answer it, that means you are not able to listen the lecture carefully. Okay, so I told you the two bulbs are connected in series. If they are in series, that means their current will remain same. No, there is no change in the current. Okay, two devices are there. Suppose we have here, these are the two bulbs and which are connected in series. Okay, so in whenever any components are in the series, same amount of current is flowing. From 100 watt it is going 1 ampere of current, and in 40 watt also 1 ampere current is only flowing. Okay, so option, which option is there? Option D is the correct option. Getting this? Okay, write down next question. What is the maximum resistance which can be made using 5 resistors? Those who are able to finish the questions, they can type the answer, okay, in the comment box, so that I will come to know that who all are solving. Write down, what is the maximum resistance which can be made using 5 resistors which of 1 by 5 ohm, which of 1 by 5 ohm. Okay, write down the options. First 1 by 5, second 10, third 5 ohm, and last 1 ohm, and last one is 1 ohm. Okay, so here what is the maximum resistance which can be made using 5 resistor, each of 1 by 5 ohm. Okay, so we will get maximum resistance when? Okay, so maximum resistance we are getting when the resistors are connected in series. Okay, when we are connecting, the resistors are in series. So here how many total resistors are there? They are saying 5 resistors are there. Okay, so here there are 5 resistors are there, and each of is having resistance 1 by 5, 1 by 5, 1 by 5 ohm. Okay, and we know that in RS we are connecting all these R1 plus R2 plus R3 plus R4 plus R5, but here all the resistors are same, so I will multiply 5 into R or R1 or R, so 5 and one resistor is of 1 by 5, 5 get cancelled, so answer is 1 ohm. So maximum resistor in this case is addition of all the resistors as they are connected in series, and we get the answer as here 1 ohm. Okay, getting this? Hruday, Advait, you both are there? Hruday, are you there? Advait, yes. Yeah. Both are copying and pasting the messages. Copy this. Write down next one. What is a minimum resistance? What is minimum resistance which can be made using 5 resistors, each of 1 by 5, each of 1 by 5. Options are given. First is 1 by 5 ohm. Second 1 by 25. C. Third option 1 by 10. And last option is 25 ohm. And last is 25 ohm. Okay. So here I will repeat, what is the minimum resistance which can be made using 5 resistor, each of 1 by 5 ohm. Okay, so here they are asking minimum resistance. So minimum, that is nothing but what? All 5 are connected in parallel. Okay, in series we are getting maximum resistance, and whenever the resistors are connected in parallel, then we are getting what? Minimum resistance. Okay, so now here these 5 are in a parallel. Okay, and this is what connected across the battery terminal, and current I comes here, and that is gets branched into different branches. So that's what this is parallel. So that's what they are asking here, minimum resistance. So 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4 plus 1 by R5. Always remember, if it is 1 mark question also, you have to write the formula and then substitute the value and calculate answer. Okay, so don't do the questions hurry-burriedly. Okay, so here 1 upon 1 by 5 plus 1 upon 5, 1 plus 1 upon 5. Okay, so this is 5 is get reciprocal, 1 by 5 is entirely reciprocal, so 5 plus 5 plus 5. Okay, addition is repetitive multiplication, so here you will get the answer 25 ohm. Okay, so this is nothing but the answer of this question. So very simple questions, but you have to understand the meaning. Maximum resistance we are getting whenever they are in a series, and whenever they are in a parallel, then we are getting maximum, then only we are getting maximum. Oh sorry, wait, here answer I got here, this as a 1 upon Rp, this I got 1 upon Rp, so R P only means we have to reciprocal this also. That means 1 upon 25 ohm. So 1 upon 25 is less no than the 0 something 0.1 we will get. Okay, and in previous case we got maximum, that is 1 ohm, and here we are getting less than 1 ohm. That means in parallel combination we are getting the resistors addition is always less than 1, that is a minimum resistance, and in series always we are getting maximum resistor. Okay, getting this? Understood? Okay, copy this. Copy this. Everyone copied? Then write down next question. Write down next question. An electric kettle consumes 1 kilowatt of electric power. An electric kettle consumes 1 kilowatt of electric power when operated at 220 volt, operated at 220 volt. A fuse wire of watt rating, a fuse wire of watt rating must be used for it, must be used for it. 1 ampere, option 1 ampere, second 2 ampere, third 4 ampere, fourth 5 ampere. Okay, I'll repeat. An electric kettle consumes 1 kilowatt of electric power when operated at 220 volt. A fuse wire of watt rating must be used for it. First option 1 ampere, second B 2 ampere, 4 ampere and 5 ampere. Okay, you can solve this. I'll come. Someone came down. Okay, you got the answer? Check once. Just wait. Yes, Devdutt. Total 3 pages are there. Okay. It is. Sorry, my 12th standard tests are going on, so kids are coming. That is quite disturbance, but no option. How much? What is the answer you got? Is anyone got the answer? So here try to understand the question. An electrical kettle consumes a power. Power is given. Okay. And that power is nothing but how much? 1 kilowatt. Correct? 1 kilowatt, that you have to convert it into watt first by multiplying 10 raised to 3. At least you can write down the given things properly. Okay. So here power is given. P is nothing but 1 kilowatt, that is nothing but 10 raised to 3 watt. This is the power given. Okay, and after that voltage is given, that is 220. 220 voltage is given. After that nothing. They are asking a fuse wire of what rating must be used for it. Okay, what rating means we have to find out here current value. So here we know that we know that P. So can we use this formula? P is equal to V into I. So I is nothing but what? P by V. So here P is nothing but 1000. 10 raised to 3 is nothing but 1000 divided by 220. Okay. Now simplify this. After simplification you will get the rating. After dividing this you will get 4.5 ampere. Okay. So current rating is here 4.5 ampere. Getting this? So 4.5, but in option I don't have that 4.5, no? So 4.5 we can write approximately as a 5 ampere. Getting this? So this is what your answer. I hope how many people you got the same answer as a 4.5? Yeah. Okay. Write down next question. Write down the next question. A student has two resistors, 2 ohm and 3 ohm, 2 ohm and 3 ohm, full stop. She has to put she has to put one of them in a place of R2. She has to put one of them in a place of R2 as shown in circuit, full stop. The current that she needs, the current that she needs in the entire circuit, is exactly 9 ampere, full stop. Show by calculation, which of the two resistors, she should choose. Okay, this is one of the sample question paper question. Okay, so those who don't know Ohm's law, they can check my previous video, and those who are able to solve, they can start solving and check with me or verify with my answer. Okay, so here I will repeat. A student has two resistor, 2 ohm, 3 ohm. She has to put one of them in place of R2 as shown in the circuit, and the current that she needs in the entire circuit is exactly 9 ampere, and show by calculation which of the two resistors she should choose. Very important question and little bit different. Okay, so that you can apply whatever the knowledge you have. And here circuit diagram is given like this. Okay, so across this we are providing supply which is of 12 volt across this combination. This is A terminal, B, and this resistor is given of 4 ohm. Okay, and this is what here R. Okay, and this R I have to calculate now, and they are giving option here. That means the student have two resistor. One is of 2 ohm and another is of 3 ohm. R1 is given 2 ohm and R2 is given how much? 3 ohm. So these are the two resistors are given. So we have to connect the resistor here in place of R, so that I will get entire circuit current is nothing but 9 ampere. So which of the resistor I have to use instead of R, that I have to calculate. Okay, everything is given. We want 9 ampere of current, and out of these two resistors I have to use one, so that I will get current as a 9 ampere. Okay, that we have to check. So here voltage is also given, no? So at least by observing this diagram, you can write down the given thing. V is nothing but 12 volt, and you know that just now I finished the currents, the resistors when we are connected in parallel and series. So here whenever current is flowing, I amount of current is flowing, then that same current here, what? This is junction, so current is gets divided and partially it is gets divided into this branch. So current is dividing means there is what? A parallel combination. You should try to find out whether that circuit is parallel and series. Then only you can able to solve properly. Okay. So this is a series circuit, and we know that Ohm's law. Okay, we know Ohm's law. What is Ohm's law? V is nothing but I into R. Okay. So here we can calculate the value for resistance, because I don't know here R. So R is equal to V by I. I will rearrange this. V is nothing but 12 volt divided by current I have 9. So 4 by 3. 4 by 3 is nothing but, you can simplify this, but 4.3 something 1.3 ohm is the resistance. Okay, we are getting here. Now here we know that these two resistors are in parallel. Okay, so these two resistors are in a parallel, and this R value I get it as a 1.3. So from this, at least can you find out the net resistance Rp? Rp is nothing but what? 1 by R1 plus 1 by R2. As I have 2, that's what I used, these two. So what I will do, this is R, no? So this is, I will take it as a R1, and this capital R I will write it as R only. Okay. So now can you simplify this? So substitute the value. Okay. So Rp, this is nothing but what? The net resistance according to the given information. So don't think कि this 4 by 3 is this R. No, this is not this R. Just by whatever the values of voltage and the total current which they gave, from that I calculated one resistance, and that resistance is R here. That is nothing but I will take it as a Rp. So 1 upon, here I will substitute R value is 4 by 3. Instead of taking this decimal, I will take fraction. This one 1 upon 4 by 3 is equal to 1 upon R1 is nothing but 4. And this R I don't know, I will keep it as it is. So this part is get reciprocal. So we can write here 3 by 4 is equal to 1 by 4 plus 1 by R. Okay. Now take this 1 by 4 to this side. So I am doing here 3 by 4 minus 1 by 4 is equal to 1 by R. So 3 minus 1, no need to take LCM because here denominators are same. So 3 minus 1 is nothing but 2 by 4 is nothing but 1 by R, and 2 ones are 2, 2 twos are 4. So here 1 by R is nothing but 1 by 2. Therefore we can write R is equal to 2 ohm. Can you getting how to find out which resistance we have to connect? So answer here for this R is nothing but 2 ohm. Okay. So like this we have to find out the answers. Okay. Those who are not able to do that, then what they can do, first substitute 2 ohm, calculate current, whether it is 9 ampere, then use that. If it is not, then again substitute 3 and check the current. Okay, like that you can do. So that is also one alternative method we have, but this is what we have, one normal and common method we have. Getting this how I did? Can you able to solve this? Everyone is getting? Finished? Take a screenshot. Who all are there? All are getting what I am saying? Write down next question. Compute the heat generated. Compute the heat generated. Compute the heat generated while transferring 96,000 coulomb of charge. 96,000 coulomb of charge in 2 hours. In 2 hours through a potential difference of 40 volt. I'll repeat this question. Compute heat generated while transferring 96,000 coulomb of charge in 2 hours through a potential difference of 40 volt. Okay, very important question. Okay, here everything is given. We have to calculate the amount of heat generated. So potential difference is given 40 volt, and here charge is given 96,000 coulomb, and time is also given, that is 2 hours. So amount of heat generated is nothing but what? H is equal to V into I into T. Okay, use this formula and try to find out the answer. Okay, chalo, try this question. Charges are given. I think today also I will keep a session online, and those who are coming here, they can come by 4 for normal practice. Okay, today we are discussing KVS question banks and all. So you all can come by 4, but before that in the afternoon I am keeping one session. So you have to attend that. So write down what are the given here. Charges Q. Q is given 96,000 coulomb. Okay, then time is given 2 hours. 2 hours. Okay, and potential difference, that is voltage, is given 20 volt. 20 only, no? Oh, sorry, 40 volt is given. Okay, so we know that H is equal to V into I into T. So we know that yesterday we did I is equal to what? Q by T. So Q is nothing but what? I into T. So this I into T is nothing but charge. No need to find out how, ma'am, here charge is given, here we have a current, use brain. So that's what every day you have to practice for these questions. Okay. If you are practicing, then only you can able to solve the 1 mark MCQ properly. Okay. See, this is one just adjustment. So V H is equal to V into I into T. So IT is nothing but Q, and V into Q. So we have 40 and Q we have it as a 96,000. Now do this calculation, you will get the answer. Answer is something 0 0. One more 0 will come. No, one more 0. Sin chok 24. 24 9 chok 36. This is what the answer, and it is measured in terms of joule. I don't know how to read the number. Write down. Getting this? Those who are online, they can able to understand how I am solving, what are the adjustments. Advait, finished, copied, everyone? Okay, write down next question. How many 132 ohm resistors, how many 132 ohm resistors in parallel are required to carry 5 ampere on 220 volt line. Okay, I'll repeat this. How many 132 ohm resistors in parallel are required to carry 5 ampere on 220 volt line? Okay, there is a voltage line given, that is of 220 volt. Okay, and this 220 volt line, and there is 5 ampere of current is flowing through this, and they are saying how many, the resistance value is given, and that resistance value is given 132 ohm. Okay, so they are asking how many 132 ohm resistors which we can use on the line which contains 5 ampere current, and the voltage line is 200 volt here. Sorry, 220 volt. So as usual, you can write down the given values. V is 220 volt, and current is given, I think 9 ampere, no? Sorry, 5 ampere. Okay, and they are asking how many resistors. Okay, they are asking. You can connect, and one resistance value is given 132 ohm. Okay, this is what the value they are giving. They are asking number of resistors which we can use on 220 volt line, that we have to calculate. So according to Ohm's law, we know that V is equal to IR. Okay, so how many resistors? Okay, R is nothing but we can write V by I. Okay, so here we can say when there is a 220 volt of voltage or potential difference, in that case 5 ampere amount of current is there. So if 132 resistors are there, then how much how many resistors are there on 220 volt 5 ampere line. Okay, so here we are interested to find here x value. Okay, so this we can find out here. So take a cross multiplication. X is equal to 132 into 5 divided by 220 and find out this. Check what is the answer. Is it 3? X is equal to 3. So there should be a 3 resistors, okay, on the line, so that they can contribute 5 ampere current on 220 volt line voltage. So this is what the answer. This is also one of the question from the sample paper. Copy this. Okay, write down next question. Consider the following circuit. Consider the following circuit. Consider the following circuit. What would be the readings? What would be the readings? What would be the readings of ammeter and voltmeter? What would be the readings of the ammeter and the voltmeter when key is closed? When key is closed, give the reason to justify your answer. Give the reason to justify your answer. Okay, draw the diagram, and here 6 volt battery is provided, and here key is given, and then here is somewhere voltmeter is also connected in between them, and this is what the circuit, and resistor values are given 5, 8, not voltmeter, this is ammeter they connected, and here we have a voltmeter. This is the resistor 5 ohm, 8 ohm, and then 12 ohm resistor. 3 resistors are there. Okay, and we have here voltmeter, and this is what ammeter. Ammeter, yesterday I told you, that is always in a series we are connected, and voltmeter we are connecting in the parallel. Okay, here the question is that they are asking here what would be the readings of the ammeter and voltmeter when the key is closed. So now key is open. So when you close it, okay, then current is what started flowing through this. Then here you know that all the 3 resistors are connected series or parallel. Tell me, someone can type. So if the 2 resistors here, ending of one resistor is connected to the starting, and current value will remain same, it is not dividing, that means it is a series combination. And here we can write RP, that is RS is nothing but what, 5 plus 8 plus 12. You have to write the formula first. RS is nothing but R1 plus R2 plus R3. So 12 plus 8 is 20 plus 5, 25 ohm. So this is nothing but what, total effective resistance of this circuit. Okay, 25. Then once you get, you know that voltage V is equal to 6 volt. So what amount of current is flowing, because they are asking ammeter readings. Okay, so ammeter reading, ammeter measures current. So I want to find out the current. So V is equal to what, I into R. So here RS will come. So I is equal to V by RS. So V is how much here, 6, and RS I got 25. So this is I is equal to 6 by 25, that is approximately we can take it as 0.25 or 24 ampere. Okay, so this much amount of current is flowing through this. So ammeter measures how much is the current, 0.24 ampere. Okay, and again we have to calculate voltmeter readings also. So here total voltage, this is a battery voltage, and this V is equal to, we can calculate as a I into R. So here amount of current is 0.24 and resistance we have to take 25. Now not each resistance. So what they are asking, across, yeah, ammeter, yeah. Now voltage we have to find out. The voltmeter is applied across 12 volt, no? So 12 ohm. So here voltage across this I have to calculate. So here it is 12. Okay. So now calculate this 12 into this current. Then you will get a drop over here. How much is the voltage? Check. 0.24 into 12 is nothing but 2.28 volt something. Check once. 2.28, no, 2.88 volt is the voltage. Okay, so this is what the answer. Getting this? Okay, so I will end this session today. Again afternoon I will let you know the timings. We can do a session in the afternoon. So and normally for not 4:30 you all have to come, 4:30 to 6:30. Okay, so I will end this meeting. So afternoon sessions link I will send you on the group.